Q8079. Forward biasing of a solid-state device will cause the device to A. Conduct via Zener breakdown. B. Conduct. C. Turn off. The correct answer is B. Forward biasing is a condition where the voltage applied to a solid-state device is such that the current can easily flow through the device. In this condition, the device conducts and allows the flow of current through it. This is in contrast to reverse biasing where the device does not conduct. Zener breakdown occurs when a Zener diode is reverse biased and it conducts due to the breakdown voltage being exceeded. Therefore, option A is incorrect. Option C is also incorrect as turning off occurs when the device is not biased or when the voltage applied is less than the threshold voltage. Q8085. A lead-acid battery with 12 cells connected in series. No load voltage equals 2.1 volts per cell. Furnishes 10 amperes to a load of 2 ohms resistance. The internal resistance of the battery in this instance is A. 0.52 ohm, B. 2.52 ohms, C. 5.0 ohms. The correct answer is A. The voltage across the external load is V equals I multiplied by R equals 10 amperes multiplied by 2 ohms equals 20 volts. The total no-load voltage of the battery is 12 cells multiplied by 2.1 volts per cell equals 25.2 volts. The voltage dropped across the internal resistance is 25.2 volts. 20 volts equals 5.2 volts. Internal resistance equals voltage drop divided by current. So R_internal equals 5.2 volts divided by 10 amperes equals 0.52 ohm. Q8086. If electrolyte from a lead-acid battery is spilled in the battery compartment, which procedure should be followed? A. Apply boric acid solution to the affected area followed by a water rinse. B. Rinse the affected area thoroughly with clean water. C. Apply sodium bicarbonate solution to the affected area followed by a water rinse. The correct answer is C. Apply sodium bicarbonate solution to the affected area followed by a water rinse. This is because sodium bicarbonate is known for its ability to neutralize acid spills, which makes it a suitable solution to use for cleaning up electrolyte spills from lead-acid batteries. Once the sodium bicarbonate solution has been applied to the affected area, it is important to rinse the area thoroughly with clean water to ensure that no residue of the electrolyte or the cleaning solution is left behind. Q8087. Which statement regarding the hydrometer reading of a lead-acid storage battery electrolyte is true? A. The hydrometer reading does not require a temperature correction if the electrolyte temperature is 80 degrees Fahrenheit. B. A specific gravity correction should be subtracted from the hydrometer reading if the electrolyte temperature is above 20 degrees Fahrenheit. C. The hydrometer reading will give a true indication of the capacity of the battery regardless of the electrolyte temperature. The correct answer is A. The temperature must be taken into account when measuring the specific gravity of the electrolyte in a lead-acid battery. When the electrolyte temperature ranges from 70 degrees Fahrenheit to 90 degrees Fahrenheit, no adjustment is required. For every 10 inch above 80 of and every 10 below BF, a correction of 0.4 should be added to and subtracted from the specific gravity result, respectively. Q8088. A fully charged lead-acid battery will not freeze until extremely low temperatures are reached because A. The acid is in the plates, thereby increasing the specific gravity of the solution. B. Most of the acid is in the solution. C. Increased internal resistance generates sufficient heat to prevent freezing. The correct answer is B. Sulfuric acid is created when hydrogen atoms from both plates combine with water in the electrolyte. The freezing point of sulfuric acid is substantially lower than that of water, and the freezing point of the electrolyte in a fully charged battery is much lower than that of the electrolyte in a depleted battery.